Hey guys, it's Vince. Today in this video we are going to take an in-depth forensic look at a system being offered by a vendor who unfortunately should not be selling this system. I've actually been approached by numerous potential clients looking to get an overview of this system, and once again I want to bring to light what many of you may or may not know, especially my novice guys looking to get into plasma systems, which are much more advanced systems. I've said it in many previous videos. These are not the normal animal of a traditional manufacturing robot. So let's start with putting some time aside. This is not going to be a short video. It's going to be in-depth. So if you only have 5 minutes, I suggest coming back to this and reviewing it, because I promise you this video easily will save you at least the $1,860 that the vendor is asking for this system. Many of you are going to look at this system and know right off the bat it's not correct. However, I want to point out in explicit detail what is not correct, and you guys can take into account what I'm stating not only by using the user's manual right here from some of the components used for the system, but also doing your own due diligence, which all of you should be doing regardless. So let's start off by looking at, this is Proma. Proma manufactures a torch height control system. They do a couple other components. They are based in Europe. Their support's pretty good. I mean, the big thing you'll deal with is dealing with time zone issues. So if you're running a business, and I've stated this many times prior, you're always dealing with a time constraint on time zone differentials. So you'll send an email today, you may not hear back for a day, day and a half, sometimes 2-3 days. Keep that in mind. So let's just overview what we basically are working with here in this system as we go through the pictures. I wanted to show you this first because you can see this is the actual board that's being used inside the plasma controller. Now it's interesting, if we read here under the general description, it states here that the MyPlasm CNC was developed especially for the needs of controlling plasma CNC cutting machine. The plasma interface, as well as the opto-isolated mainboard, was designed in a way enabling an elimination of all hardware and software interferences, thanks to which the system is resistant to any high frequency and high voltage interferences generated by plasma sources. That's a bold statement. And when I say a bold statement, I have yet to find any electronics that is totally impervious to high frequency and high voltage interferences. And that would go from my military guys out there. You can confirm that as well. Anything electrical is going to have its own culprits, so to speak, when it comes to EMI. What I find interesting here is that we look here, it says resistance to high frequency, high voltage interferences, 10 kilovolt, 500 hertz. And it says test lab 12 kilovolt. And then as we come over here, it says type of step direction output is common 5 volt, which is normal for any step and direction. What makes this unit completely, or I should say very interesting, is the fact that it is a USB type controller. And anyone familiar with USB can look this up, or again, in detail as far as what the actual USB consists of. It is a 5-volt signal that powers USB from your PC. Okay? The power supply that this unit accepts is 24 volt. That's what they're basically recommending. They're saying test lab is 7 to 35, so we know the max and the minimum that it will accept. Using a 5-volt signal to actually control step and direction from a USB input on a PC is questionable with plasma because it's so low a voltage, it's very, very susceptible to EMI. So what they did, and I'm just going to basically abbreviate this in a nutshell, if there's not a filter in place, which there may very well be to get to these kind of voltages, there would almost definitely have to be. But the main thing that they did here is they increased the power supply that the unit uses to 24 volts. So every time we go up in voltage, we mitigate any potential for EMI interference. The higher we go up, the less EMI that can actually interfere with the signal because we have a stronger voltage that we're working with. Common sense, real basic. You can check this out yourself. But this is basically where we're going with this. And I'm going to cover why we're covering this in detail. As we come down, you can see here that we have a general connection scheme. And you can see what we've got here, and they're breaking it down. Real simple wiring diagram, actually very well done. And it says long line to plasma interface, and you can see here it's got a shield. And what they're trying to implement is shielded cable. Now, I'm going to redirect your attention to some areas of the system we will be discussing. Here is the first picture of the system as far as motor interface. And yes, I said motor interface. This is the plug port for your motors. Okay, we can already see we have some issues here. First issue being, this is some type of plastic tub. I have no idea what substrate this is made out of. Once again, I am not going to disclose the vendor. I'm not going to disclose anything about them. I will say that the vendor does sell tables, and their tables typically are fine, but they now just decided to start selling controllers. And again, if I see things that are blatantly wrong, blatantly incorrect, that number one, many of you are going to pick it out yourself, but on top of that, unsafe, I'm going to warn anybody. I will not do this to just anybody. I will only do it if there are extreme cases, in which case this is certainly extreme. Namely by us using a plastic enclosure when we're dealing with high frequency EMI, and that's done from plasma systems. So many of you already know you cannot ground plastic. That's impossible. So that already is a red flag. Second red flag, we're using Ethernet connections for motor cables. And I'll state that again. We're using Ethernet connections for motor cables. And banana plugs for, I'm assuming, his floating head. This gets more frightening as we go on, but once again, I want to start, and we're going to go through everything. We'll analyze it together. Let's go inside this unit. Okay. Here is the inside of the unit. And again, we see what he's doing here, or what he's trying to do, is he's using braided wiring to mitigate EMI. Okay. Now, this is not best practice when we're dealing with the high frequency or EMI that we're working with plasma systems. This is not nearly as effective as using proper double shielded cable or passive filtration as ferrites. Okay. Again, this is being done in mitigation of that. And on top of that, what's really interesting is in the manual of this controller that he's using, it states once again that we are using shield on our cabling. So if we're using shielding on our cabling, we already know that what they're trying to tell us is you should be using shielded cables all the way across. Here is the THC and ohmic sensor. Here it is right here. And once again, we already see that whoever this person is didn't even take the time to read the manual, let alone if they did read the manual, that's even more frightening in the sense that they're not following what's being said. Okay? So we can see here we have our Chinese drives all broken down, no big deal. If we analyze the enclosure a little deeper, we notice that there's our Ethernet jacks, and we also see, or I should say don't see, a cooling fan. Okay, and yes, these Chinese drives do have heat sinks built in, but a heat sink is only as effective as the cooling fan that's going to remove any of the stagnant hot air that's produced. Okay, if this is going to be in a shop environment, you already know that the unit's going to get hotter than the ambient temperature, just due to the fact that we have voltage going through all these components. So again, I'm trying to do a split screen here, and I'm giving you a complete breakdown of why I'm doing this. So once again, we already know that this was totally ignored in the user's manual, okay, from this system being built. Let's move on. We then come over here, and I've got my little cool magnifying glass, and we're going to go inside the system now, and I'm going to just move these over so we can see what we're looking at. You can see we've got our power supply mounted on the door, okay. Here's your banana plugs. I'm assuming this comes with the unit. You can see here's all his twined wiring again. But here's where things get really interesting and once again get dangerous. As I come up here to look at and magnify the fuse, you can see that nothing is insulated there. Okay, the magnification makes it real easy to view, and if we want to go bigger just to make sure I'm not making things up, you can certainly see there's no heat shrink applied there at all. Okay, we go out a little bit. Now, let's go to the next phase. I'm going to come back to this in a moment. On the actual power in, this is the switch, you can see here that the cable that's feeding power to the switch, there is no ground. Once again, I'll state it. There is no ground. You do not see a green lead at all. What we actually see here is it passes over from the switch, comes over to the fuse as it should, comes into the power supply, and then there's a green lead coming out of the power supply. And if we just come down, this is where things get really interesting. Come down, you can see we have a terminal block, and this terminal block, what makes it so interesting is it looks like he's using it as a terminal splitter. The interesting thing I want to point your attention to is these terminal blocks I've used many times. I've actually used them on my first revision solderless connector for the G540. These are isolated terminals, meaning that these are not joined, in that once you make a connection like you see right here, and there's another connection here, this is a straight through connection then. If I connect a wire here, and there's not a jumper coming from this block to this block, this is separate. So now again, I'm being in all fairness, I do not see a bridge here, which is to be used to join all these together where one lead would then split these all out. He may be using it, we just don't see it. But I must say, in all the years I've been dealing with these type of electronics, I have yet to not see a bridge be present, or not a picture of it be present, when you take a picture of the terminal block. So let's put this in a questionable field. The next thing you see is the same thing here. With this area, you still don't see a bridge. So I'm not exactly certain how he's doing it. It must be done in that format. But when we look back up here, and we do not see a ground, okay? A ground coming in from the power, you already know that's a huge red flag. Not just for stability on the most difficult system to get stable in the CNC genre, which is plasma systems, due to the amount of amperage being drawn by your torch, but it is a huge safety factor that this unit is not grounded. Now, maybe that to him is not a big deal, considering he's using a plastic box which is not conductive, but this is totally incorrect. If there is a ground attached here, the only thing I could see here, we see a black lead coming in, we see a white lead. There is no green lead except on the power supply. So I do not know where he's getting a ground lead coming in, but we do know for certain this is the power cord. And you can see how this is done. He made some kind of pass through here where he just slid it and brought the cord in right to the actual switch itself, instead of actually jacking it or using a typical jack with a power port. He didn't do that. So either way, what we have here, something is seriously wrong and seriously missing. Now, that being said, I want to point your attention, we'll get this out of the way. I want to point your attention to the actual power supply. Now, we know that from what we just read in the user's manual on the actual board that he's using, that they recommend 24 volts, and it can go up to, I believe, 35. So let's give or take, we'll say we don't know what this is rated at, but let's give or take, say it's 24 volts, okay? Now, if we're using a 24 volt power supply to power all of our electronics, which we're assuming on the low end, because I can tell you right now just from the size, that's most likely what he's doing, and we come over here, once again, let's see if I'm in the right spot. Okay, I am. Okay, we come over here, we already looked at this. Let's come over here. If we're running 24 volts, you can see this is the contraption right here, and he's using monoprice, because we can see down here monoprice on his cables. He's using monoprice Cat5 cables to actually run power to his steppers. Okay, these cables use 24 gauge wire inside them. Now, any of you guys not familiar and just getting involved with CNC will realize real quick that 98% of the steppers out there, minus NEMA 34, the NEMA 23 versions, typically come with 22 gauge to 20 gauge wire. Usually it's 20 gauge. Some of them come 22. It all depends on the manufacturer. When you go down to 24 gauge wire, and you're using a Cat5 cable to draw power, he's running 24 volts through this cable, and each one of these, I don't know if you guys can see that right there, but it is at 25 feet in length. Now, many of you already know these cables aren't designed to run that kind of power. That's not what they're designed for. The leads in them are so thin that what ends up happening is, as you go in great distances and easily past 5 feet just due to the thickness of the wire, we'll cover that in a moment, but what ends up happening is you have a power dissipation. It'll start losing voltage because you're going greater distances. That's the one fault. The major fault that we have, okay, is the fact that if you did decide to use this for this particular application, you are going to find, come over here, we go to the engineering toolbox. You can go on their website. It's right here, highlighted. I highlighted all the areas that are important. You can see here on 24 gauge wire, the diameter is 0.51 millimeters. I'll say that again. Its diameter is 0.51 millimeters. The typical max current load ratings on this cable in a 4 to 6 core ratio is 1.6. That's the maximum heat that that cable can withstand. Okay, and I didn't say this. I'm just showing you what's fact. Okay, so we look at this 4 to 6. Now, give or take, do we know that this site's completely accurate? Of course not. We know there's tons of sites online that are like this, but I can tell you it's very, very, very close. Okay, that being said, we look at that, and then we come over to the motors that he's using these on. And how do we know that? Because I got my little zoom in box here again, my neat little tool. And I can zoom in on the part number of the motor, and therefore I already did the research on the motor. Here is the motor he's using. He's using a 6-lead motor. How do we know he's using a 6-lead motor? Because if we come over here, you could see some cut leads. You see how I magnified that? You can see those cut leads. So he's using a 6-lead motor where, again, not a big deal. You can use bipolar. He's not using bipolar. He's using a unipolar motor. And the issue with that is that the motor's current is 3 amps. Now, before you guys pass out, because many of you assume that that motor's taking full 3 amps, it's not. When it's hooked up in a bipolar format where we see 4 leads here, 1, 2, 3, 4, he cut 2, remember. So those are your center coils that are being cut right here. When he hooks it up in a bipolar format, that means it only requires or it's actually pulling no more than 1/3 of its amp rating. So it's still pulling 1 amp from the power supply. Okay, now let's look at this again closely. Once again, cut leads, running 4 leads, 1, 2, 3, 4. We know that. Here's his Ethernet connections. You can see the double leads going in because, again, that's it's typically not what it's designed for. As we go through and we look at this in more clarity, we come back over here. We know that he's running, literally, he's giving himself basically a 0.5 amp differential between the absolute max heat rating of the cable. Now, many of you already know and should know. If you don't know, ask. You will never ever want to stay that close to any maximum heat rating on any cable. Okay? My recommendation is never go past 70%. That's usually your sweet spot. Now, again, this is just one area on a website. So each website will say something different. I'm going to tell you right now, to run 24 volts through a Cat5 cable running 24 gauge wire on a motor that's pulling 1/3 of 3 amps, which would be 1 amp, we're looking at a very, very, very tight edge, so to speak, of falling off the cliff with heat. Not to mention an extreme bleed off at a length of 25 feet because, again, your wire is so thin, you're just not able to carry that kind of power stably to where it starts at 24 volt and as soon as it gets past 3 to 5 feet, it starts bleeding down. Okay, so definitely not a huge deal with that in terms of speed because that's all the voltage drop will do. But when we start looking at a power consumption of 1.6 amps at max, that can lead to overheating and potential fire. Once again, Cat5 cables are not designed for what he's doing, which once again means this is a hack job. Okay, this is simply not designed for that. If it's a plasma system, which is what he's trying to sell here, the thing to realize is that these cables, unless specifically stated, they are not double shielded. And you can see here the exact thing that's listed. Typically they have single shielded cables. And again, for what you're doing with the plasma system, due to the high amount of amp draw, due to the requirements with grounding, which we're about to cover once again, which I've done numerous videos on, this is completely unacceptable, and I put it in a line of being unsafe. You be the judge yourself, but if you do your own homework, most people are going to laugh when they tell you, you're running 24 gauge wire to power stepper motors on a machine at up to 25 feet. That's just completely illogical. But we know why that is. And if we look right here at the price of these cables, now we know, and that price is correct for a 25-foot cable, guys. So again, think in terms like this, and I've stated this numerous times. When I tell you guys do your due diligence, and I tell you that these videos will save you money, let me explain what I mean in complete clarity. At $3.66 for this cable, you're going to use this on a robot that's costing you thousands to produce parts, preferably to sell, and that's the kind of equipment you're using. The drives in this system, unless they're lead shine, I can tell you right now are probably $25 to $30 a piece. Okay, what quality ratio do you put at that price? That's what I'm asking you. And I'm not saying you can't get great quality stuff overseas. That's not true at all. I'm not saying that. But what I'm saying is, when it comes to robotics, when it comes to manufacturing, you do get what you pay for 98% of the time. This is completely illogical. Okay, what we're seeing here is showing that whoever fabricated this system, I don't really have to say much about this picture. Something is missing. Okay, now let's go in depth even more. Okay, maybe I'm just biased. Maybe because I sell controllers, I'm just a biased jerk. Okay, because I get told that sometimes. Let's look. Here is the remaining portions of the user's manual. And we're going to go through, actually, we'll start over here. Due to very significant interferences generated by plasma sources, one should follow below tips. Switch, motor, and then I'm assuming this right here is going to be for his floating head switch. You could see shielded cable. And you know what's interesting? Shield drain, shield drain, shield drain, all going to the ground on the cord. And he says separate. See down here it says separate. It says earthing of electronic parts should not be connected to earthing of the machine construction. Electric control box should be isolated from the machine and earth only from a supplying network. This is direct from that user's manual for the plasma control board. Now, I'm asking you a logical question because once again, I could be a jerk. This box that the system is built in is plastic. How do you ground it? I thought so, because we covered it already. You guys are paying attention, so I know you're listening. So we already know that's not possible to be done. Okay? One should use shielded wires, and shielding would be connected only from one side of the CNC control. I get that question all the time. Grounding seems to be this mythical beast that everybody has such trouble with. And really, it's one of the simplest things to do once you understand the principles of what you're trying to accomplish. Don't worry about always learning to do it. You always want to understand why. And the reason that you'd want to only ground one side is that we then don't have the potential for ground loops. That is why we do not want to connect both sides. Now, there's been new releases in information that state grounding both sides is okay to do. And I've stated this many times before. It's up to the end user to decide what is tried and true in practice. I can tell you that is a new characteristic that has just been come to light, so to speak, in manufacturing. It can be a hairy situation in most cases. What we know definitively that works and has worked for years prior, okay, because I'm still old school, is grounding one end. You will never go wrong there. You can see here machine ground, and this is interesting. If we look here, this would be done with the grounding rod to ground the chassis. I get asked that all the time, and once again, I've done a video directing from Lincoln Electric plasma systems that actually cover in a PDF the proper way to ground a plasma system. And again, seeing this, you already know you can't ground the RJ45s that he's using on that system, because if you come over here and look, actually we'll go to the inside, we don't see any grounds going anywhere. The only thing I believe, actually I'm wrong, I stand corrected. I think what he's doing, and I'm doing this with you guys, so bear with me, I'm just going through all my pictures, and there's quite a few. What I believe he's doing is he's taking these right here, all these grounds, and going from here right to the ground on the power supply. Okay, that green lead is the ground, and it's coming over here to the terminal block and splitting all those to the actual drives, I believe. It could also be coming from the Ethernet. The only question I have is, why would you have 5? He's only got a 4-axis system that I see. So again, I don't know where those 5 leads are coming from. I'm assuming that's what it is. So potentially he may have done that. He may have actually grounded everything. Unfortunately, the power supply isn't grounded. Because we can see that right here, something is totally amiss, especially when you can see here's the power input on the drive, or on the unit itself, and we only see 2 leads, okay? And certainly not a green one coming in. So, again, hit and miss at best. This is terrifying, to put it mildly. I don't know why this is being offered on the market. I don't know. Again, I'm very familiar with this vendor. I've actually worked with this vendor on table purchases and individual Proma components, because I know they do import components. But this is shocking to me because I've never seen a controller offered. And again, I will only state what I know when someone comes to me, and if it's a blatant disregard, not only for safety, which once again we're missing a ground here completely. When I see that, or I see just a really ridiculous price rating for something that is completely shoddy, it's scary, because most of the time you guys go and buy these systems and then you find me after the fact, and I always get told, man, I wish I would have found you before. And that's what I tell everybody, do your due diligence, go through, review this stuff. You can see exactly what I'm seeing. Again, looking at this is the next step. We've already reviewed this part. Then we come over here down again. It says step direction signals from a controller to controllers of stepper motors should be made, pairs of twisted wires as specified in the scheme. Now guys, I'm going to tell you right now, that's an old theory, and it works well with twisted wiring to mitigate EMI and RFI. The issue is it's not as effective overall as using ferrites, number one. Number two, when you think about it, which is easier to do, snap a ferrite on or sit there and individually weave each wire? Enough said. Signals of termination sensors should be fed by separate wires. If not, recommended separate wires on machine, e.g. in order to lead power to sensors, it can lead to increased sensibility to interferences. Again, they're trying to keep everything isolated. We know that. We already know there's all kinds of problems with this system. In order to connect MyPlasm CNC and plasma interface modules, one should use a shielded wire of the length of up to 15 meters. Shielding must be connected only at the side of MyPlasm CNC controller to the RS-485 clamp. And they're showing you some type of diagram. They're telling you to use high-class USB cables, simply means high quality. And overall, we know that you cannot do basically anything, because the interface module is telling you to use the shielded wiring, and yet when we come over here, where are you using shielded wiring? I mean, he's using banana plugs that are bolted in. This is, like I said, I don't know where to go with this. And once like I said, potential client sent me this, asked me questions on it. These are the things I draw blanks on, because when I read a user's manual like you guys do, and these are excerpts direct from the user's manual, how is it possible that you would miss this unless you never read the manual or you completely disregard it? This is scary. And that's why I said this is stuff that is not right, because someone unlucky enough, unlike yourselves, to not watch this video will go out and buy this, buy a table, or potentially buy both or whatever in comparison to them, and then find out what's going on here. And let me clarify something that's never discussed. And I really want to paint this picture because I'm a vendor. So let's say this is my component right here, okay? And I've never used this component. I don't know how good it is. I know Proma, like I said, makes a THC. I have used that in many of my systems, and it works well. It works as good as any other THC in general. THCs are about 85 to 90% of the time accurate. It's all based on the warpage of the material. But the interesting thing is that this company is really not getting a fair shake. And what I mean to say by that is, let's say somebody buys this system, contacts the vendor and says, you know what, I'm having this problem with stability, I'm having this problem with that, the other thing. And what ends up happening is he says, well, you need to, and I hear this all the time. I'm hearing this all the time. You need to buy this, or it's your fault. You need to do this to the table. You need to do that. You end up going down this long, long, deep hole in the rabbit trail, and you find out you're going down this rabbit hole and you've covered all the bases that you know that the vendor can state. And then what ends up happening is they start picking apart components. Then the end user goes, well, you know what, this board's crap. Meanwhile, it's not the board that's crap. It's the way the system was built that integrated the board. That's an interesting point, isn't it? Because it's very, very seldom discussed. We hear about how shoddy equipment is, and don't buy this and don't buy that. And, that's one thing I do love about Gecko Drive is the warranty. I've discussed that. Proma offers a decent warranty as well. The issue is that a vendor like them that's international selling this board and this individual then installing it the way he has in his system, any issue that now becomes apparent in this system becomes apparent for this board and also the manufacturer, because the end user typically doesn't know what the problem is. So guess what? Then they get a bad reputation just out of being, so to speak, friends. Like you always hear, people judge you by your friends, or at least that's an old saying. And that's exactly what ends up happening here. They never get a real fair judgment of the quality of their systems because of the simple fact of who they're associating with. So I want you guys to really take that into account. You got to be fair with what you're looking at. And I say that because a lot of guys will say, well, this board sucks because I've had it in my system and it does da 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 da. But then they show you a picture of this and it's like, well, you sure it's the board? Because when I see this, I see a nightmare. This is just a nightmare. Here's another question. How do you service this? How would one of you go about tracing all these wires? Is that what you're going to do? I mean, let's say one of these drives go out, these whatever they are, one of them go out. How would you go about servicing this? I'm assuming you're running a business, so how would that be? Doesn't make sense. I mean, you could be there for hours trying to service that. So again, when I break down the component usage in my systems, when I break down the graphics in my system, that's what I cover. That's why I cover it, because many of you are going to be alone at one point or another. And many of you are going to experience downtime from a system failure. It happens to every piece of electronics that we own. The difference is that who engineered it is going to be there at all times. And many of you forget that. Keep in mind that the diagrams I present on my systems, I do because in the event something fails, you can service it. It makes my job easier because I've taken the responsibility to say, I'm going to take my knowledge and make it present all the time so the end user can utilize it to make sure that their system is always running, pending they, of course, have extra components on the shelf. If this thing fails, if any of these fail, you have to trace everything back. Now, for a drive, it's not as big a deal, but anything else here, you have no idea. A typical end user who is not familiar with CNC at all, they are lost. They are absolutely lost. And I can tell you because 94% of my time, and I'm being lenient there, 94% of my time is spent with answering questions. And it's not, remember, the people that are asking questions are generally not the ones that, haven't or have experienced CNC robotics. It's the ones that are getting involved. And believe me, it's happening at a rapid pace. And this is why these systems are rampant. And I've discussed this many times, is because the pricing keeps dropping and these guys say, oh, I can make money. And here's how they make money, off the people that don't know. So what they'll do is they'll sell contraptions like this that you see here using Ethernet connectors, using motors that are rated well above the rating of any power source for a cable that, once again, is never at all been designed to carry power. It's actually designed, like many of you already know, Ethernet is designed to carry a signal. That's it. A very, very low voltage signal. That's it. But when you see something like this, and again, I don't know what to make of it. I don't know what to make of somebody trying to sell this, and let alone $1,860. I'll say that again. They want $1,860 for this. Okay? Frightening. And all I'm telling you guys is take your time, read your manuals. Once again, the manuals are everything, and this is something you cannot ignore. When you see these kind of diagrams, and this is really well broken down. I mean, everything you see here, optional limit switches, they've got the floating head switches. I mean, they're really trying, the manufacturer of the board is really trying to go out of its way to make sure everybody understands. They're showing you the twirled cables coming in or leads going into the actual drivers and everything. I mean, it's a very basic breakdown. The question is, why would somebody ignore this if they read it? They wouldn't. They wouldn't, especially if it's a business trying to be successful. It makes no sense. So again, I think I've made my point. I mean, you guys can see here, again, using banana cables or banana plugs on cables. We don't know what the hell this is for, but none of this is shielded. I can tell you that right away. I just don't understand this. I'm looking at it, and the more I look at it, and believe me, I studied this for a couple days, it just does not make any sense to me. You can see here the wiring in the chassis, the way everything is set up. I just don't get it. I mean, and it's certainly not a price variable, because when I look at this, I'm not even in just components alone. We already know. I mean, everybody knows that basically going through this, the components are dirt cheap. The most expensive part here I see is this board, because it actually is name brand. Everything else is relatively cheap. I'm not understanding it. I'm just not. So again, guys, I hope I've made my point, and I hope you do your own due diligence. And I can honestly say, because I get asked this a lot when people send me pictures of things like this and say, you know, whether it's a used system or a new system, and they'll say, will you please look at this? And I say, yep, my charge is $50. And I'll have guys that'll say, man, that's expensive. And I say to myself, really? It's expensive in comparison to you dropping, in this case, $1,860. I think we need to be realistic in what we're looking at. Because let me tell you what, you pull the trigger on something like this, how do you rectify it? Are you going to contact your charge? You're going to go through the whole return process if you understand it. Many guys I talk to don't. I'm sorry, they don't. And what ends up happening is they piss the money away. And then right now money is really tight. We're dealing with this COVID thing, and some people working, some people aren't, some people are looking to start, do a startup. This could be catastrophic. The last thing you want to do is guess. To pay $50 in my eyes to save that kind of money is crazy. And again, I never ever want to tell anybody to do something I wouldn't do myself, and it's certainly not that I don't make mistakes, but when I pull up users manuals for the components, which we can see right here, it's pretty much cut and dry, guys. I mean, this stuff is not rocket science. A lot of it is common sense as far as electrical, but you know what? It's okay to say you don't have the experience to analyze this stuff, and that's why many of them come to me with these pictures, because they want to, this looks good. What do you think in terms of, the price looks good? That's usually what was most attractive. Oh, the price looks great. How come this is hundreds less than your system? Well, now you know. I mean, I don't know where to go with that. It's a night and day difference. I mean, it's night and day. And like I said, once you guys make mistakes, these are hard to rectify, because you got to try to resell this. The other factor is, if you sell it to somebody, are they going to be happy with you? Because once they find out what you sold them, I doubt that. I really doubt it. So like I told you about that story about people judge you by your friends, no different as far as the vendor of using this board installed in this controller. If you sell it to somebody else, you're basically just passing your nightmare on to somebody else. And then they look bad upon you just because you sold it to them. And that's the truth. That's what you're dealing with. So again, I hope the video has been helpful. I hope you guys do practice due diligence. I am always here for questions, consultations. I do them all the time. Used equipment, get it all the time. Stuff like this is very prominent. Not as prominent on older systems, because older systems typically are built from old school type manufacturing facilities, vendors of actual full-scale type electronics. But this is, like I said, this is definitely one of the worst systems I've seen. So guys, please be careful. That's really the end-all be-all. Be careful with your money. Times are tough right now, extremely tough to some. Let's not forget that. If you guys want to start a business, please do it right. Ask the right people. If you don't have the right people, take your time, man. There's no rush. I'd rather you save your money and do it right, or go somewhere else and do it, than to do it to where you're going to be burned. And then, like I said, then what ends up happening is you get all bent out of shape because now you spent the money, and you got to deal with your better half, and she's yelling at you. It's just not worth it. Take your time, ask the questions. You could ask this vendor questions, as a matter of fact, if you do find him, and you can ask him, why isn't a user manual followed? I don't know what he would say. I don't. But either way. So again, guys, if you have any questions or you require quotes, please message me direct at storm2313@gmail.com, or you can message me through my eBay store. Again, this time of year things are getting crazy. We're still in peak season, so please be patient with me, and I will get back to you as soon as possible. To all of my subscribers, guys, I love you all. You've been supporting me from day one, and again, I hope that this video saves somebody. I really, really do, because it's a lot of money. These systems are a lot of money, and when you make a mistake, especially for somebody who's just starting out and so excited to get into it, and then they think, oh, it's plug and play, I'm all set, and then they get it, and they're like, oh my God, where do I begin with this? So again, please use caution. Thank you all. Take care.